So we're going to start with this definition. The definition is that a function f is called an antiderivative of f on an interval I if f prime is equal to f for all x in I. So basically it's just saying if I give you a function and I ask you for an antiderivative, I'm just asking you for a function that if I differentiate that function, I get f. Okay, that's all. So as a quick example, just look at a simple function, f of x is equal to x. Okay, just the line through the origin with slope 1. And if I were to ask you, give me an antiderivative of this function, you might say something like, oh, okay, well, what about f of x equal x squared? If I take the derivative of this, I get 2x, which is not exactly the same as x. So what I'm going to do is just divide by 2. Now you'll note that f prime of x is equal to 2x divided by 2, which is just x. So this is definitely an antiderivative of this function. Here's my antiderivative, and it's of this function. But there are more. Okay, so you could also have told me, oh, here's another antiderivative. Let's say g of x is equal to x squared over 2 plus 10. If I take the derivative of this function, I get g prime of x is equal to, so this is x plus 0, and that's definitely also equal to x, right? So this is yet another antiderivative of this function. And I can keep going, right? I can say, oh, well, what about h of x is equal to x squared over 2 minus pi? And, of course, this is also an antiderivative. So what you'll notice is there are actually a whole family of antiderivatives. There are infinitely many, actually. So any function I give you, you can find infinitely many antiderivatives. The most general antiderivative, so the most general antiderivative of my function, f of x equal x, is given by f of x equal x squared over 2 plus c, where c is just a constant, right? So we have infinitely many. It's this whole family, and we call this expression the most general antiderivative. It's the whole family. And if you think about, well, what do all these antiderivatives look like? You could sketch them all, and they are basically all just vertical translates of each other. Okay, so this would be like my f. G of x is somewhere up here. If I scale up by 10, if I go down by pi, I have my h. So they're all just vertical translates of each other, and there are infinitely many of them. So you might be wondering, well, how do I find antiderivatives? You don't really have to know anything that you didn't know before. In order to calculate antiderivatives, you just have to know how to differentiate, and then you just go in the opposite direction. So instead of differentiating, now you're going to move in the opposite direction, and you're going to ask, what function did I take the derivative of? The example that we just did is if we have an expression of the form x to the n, instead of applying the power rule to get the derivative, we're actually going to do the opposite. We're going to add 1 to the exponent, okay, and then we're going to divide by that number. So that's how you find the antiderivative. You just sort of do the opposite of what you did when you took the derivative. Add 1 and then divide. If you recall, when we used the power rule, what we did was we multiplied by n, and then we subtracted 1. So we're really just doing the opposite to undo differentiation. And if you recall, when we took the derivative of ln x, we got 1 over x. So now in this case, if I want to find the antiderivative of this function, I'm just undoing that process. E to the x, since it was its own derivative, then of course it is its own antiderivative also. And you could look at the various formulas here. So if you're looking for the antiderivative of a basic function, you could just use these basic formulas, which are basically just the undoing the differentiation formulas that we had before. Okay, so let's do a quick example. So we are going to look for the most general antiderivative. And remember, that's the antiderivative with the plus c. We want the family of all functions such that if we differentiate them, we get this guy. So we are asking, what do I differentiate in order to get this function? If you recall, we can undo the power rule. So I am going to use that formula, and I'm going to add 1 to the exponent, and I'm going to divide by that number. Okay, so I'm sort of doing the opposite of the power rule. Now I know that if I differentiate cosine, I get negative sign. This is positive sign. So what I'm going to do is I'm going to write a negative cosine of x here. And if we go back to the formula, you can see that that is also, here I have sine x. That's my function. If that's my function, then this negative cosine x is my antiderivative. So you can use the formula, or you can just sort of reason it out. I know root x is x to the 1/2. So again, I'm going to use that undoing the power rule, and I should have an exponent of x to the 1/2 plus 1, and then divide by this quantity. Now I'm just going to clean this up a little bit. 1/2 plus 1 is equal to 1/2 plus 2/2, which is x to the 3/2. And I'm dividing by that same number. And I'm almost done. Remember, dividing by the fraction is the same as multiplying by the reciprocal. And I cannot forget the plus c, because remember, every different constant gives me a different antiderivative. So this is my family. This is the most general antiderivative. And one thing you should always do is you should always check your work just by taking the derivative. So if I check this and I take, okay, f prime of x is equal to 10x to the 9th over 10 minus the derivative of cosine is negative cosine, or negative sine x, plus 2/3, that's my constant, times 3/2 x to the 3/2 minus 1 plus 0. So I just calculate this out, and I get x to the 9th plus sine x. These cancel, plus root x. And then I go back and I check, is this the same as the original function that I had here? And it is. So I know that I'm done. So let's do another example, and again we are looking for the most general antiderivatives. Remember, that's the antiderivative plus c, and then of some function. So when we first look at this function and I ask myself, what do I differentiate to get this function? I really have no idea. This doesn't look like anything basic to me. I could go over and look at the table of formulas. So here are the table of anti-differentiation formulas. I don't see anything that looks like that function here. These are only very basic functions, so I'm kind of stuck. So the first thing I'm going to do is just rewrite this function as 10t over root t plus root t over root t. And once I do that, I realize this is just 10 root t plus 1. And now this looks like something I can find the antiderivative of, because this is just, I look at this separately as 1, and then I can look at this as 10 times root t, or 10 times t to the 1/2. And then this I know how to deal with, just undoing the power rule. So let's go ahead and do that. So I'm going to be looking for the antiderivative, the most general. And in this case, I have 10 is just a constant multiple. And then I have t to the 3/2. We just did this in a previous example, plus t. Okay, and then I have to have my plus c, right? So in this case, I end up with an antiderivative of, let's see, 20/3 t to the 3/2 plus t plus c. And then, of course, I'm always going to check my work. So is it really true that this will give me my original function? So I have 20/3 as a constant multiple times 3/2 t to the 1/2. I just do the power rule here, plus 1 plus 0. And then this leaves me with 10 root t plus 1. And does this check out? And that exactly was equivalent to my original function, so we're done. So this is fine, and this is my final answer. So here we have an example that's slightly different in flavor. We are also being asked to find the antiderivative of f. Note, we are not being asked to find the most general antiderivative in this question, just the antiderivative of f, that satisfies a given condition. So here's my function that I would like to find the antiderivative for, and here is the given condition. And the condition is that capital F of 1 is equal to 1/6. So this condition is actually going to help us find a value for C. Okay, so let's start this process. So the first thing I'm going to do is do exactly what we did before, which is just first, just find the most general. Okay, and in this case, remember, that's just the one with the plus c. So same process we did before, so let's start there. In this case, I have capital F of x, so here's my antiderivative. I'm going to look at this term to the first and just break things down. And this, if I pull out the constant multiple, I know that the antiderivative of x squared is going to be x cubed over 3. And then if I look at this term by itself, I see a 2 times 1 over x. And I know that this is the derivative of the natural log function. In order to make this the most general antiderivative, we're going to use a natural log of the absolute value of x. And then, of course, I have, to make it the most general, I have my plus c. So this is the whole family of all antiderivatives. So how do I find a specific antiderivative that satisfies this condition? Well, all I'm going to do is I'm just going to plug 1 in and 1/6 in, and that's going to allow me to solve for C. So in this case, let's do that. So I have and I end up with this expression. Now, if I just simplify this a little bit, I get 7/6. Natural log of 1 is 0, plus c is equal to 1/6. So this gives me c is equal to 1/6 minus 7/6, which is just equal to negative 6/6, kind of hard to say, which is equal to -1. So c is -1. So the antiderivative that satisfies this condition, okay, the antiderivative that satisfies this condition is basically going to be this most general antiderivative where c is equal to -1. So let me just write that out. So I have 7/6 x cubed minus 2 times the natural log of absolute value of x minus 1, and that is my final answer. Now, as I always recommend, you can check your work. So you can take the derivative here and make sure that you get f. So this is going to give me 7 times 3x squared over 6 minus 2 times 1 over x plus 0. And this is just equal to 7/2 x squared minus 2 over x. Okay, so is this the same as the original function here, 7 half x squared minus 2 over x. This indeed is equal to f of x, the original function f of x. And also we note that I just double check is if I plug 1 into my antiderivative, do I get 1/6? So I'm also going to check that too. So is f of 1 equal to 1/6? Sixth. And if I do that, I get, so this becomes, let's see, this becomes 7/6 minus 0 minus 1. And that indeed is equal to 7/6 minus 6 over 6, which is equal to 1/6, and that checks out. So everything checks out, and this is my, ends up being my final answer.